4 telescopes, 1 interstellar visitor, and a revelation that's detonated across astronomy. For weeks, the world's most powerful eyes, the James Webb Space Telescope, Hubble, the Very Large Telescope in Chile, and NASA's Spherex mission have all locked onto the same target, 3I Atlas, only the third confirmed object ever known to come from beyond our solar system. What they found? It upended comet science from the ground up. James Webb cracked open its chemistry, and the result simply shouldn't exist. Hubble captured images that broke every rule we thought comets followed. The Velt revealed elements that rewrite the textbook. And Spherex, it spotted a nucleus so massive, scientists were left speechless. Piece by piece, the mystery deepened, until finally, the verdict was undeniable. Atlas is not the comet we thought. It's something stranger, something bigger. It started with James Webb. On August 6th, Webb's near-infrared spectrograph zoomed in on the shimmering haze around Atlas, the comet's coma. What it found was staggering. Instead of water vapor, the usual hallmark of any normal comet, Atlas was saturated with carbon dioxide, a ratio of CO to water higher than anything we'd ever measured. Imagine a world where water is barely there at all, dwarfed by oceans of frozen CO. That single discovery flipped decades of models on their head. Suddenly, comets from other star systems weren't behaving like ours at all. Webb wasn't just showing us data, it was throwing down a cosmic gauntlet. Our rules might not apply out there. Then came Hubble's turn. On July 21st, its camera zeroed in on Atlas's nucleus and coma. The size estimates? Wildly inconsistent, anywhere from a mere 300 meters to over 5 kilometers across. The shape? Irregular. The activity? Unprecedented. No clean water jets. No typical exhaust. Instead, a baffling, symmetric outflow. The comet wasn't venting like anything we'd ever tracked. It was rewriting the playbook. In Chile, the Very Large Telescope pushed things even further. August 21st, its instruments caught the unmistakable fingerprints of cyanide and, shockingly, nickel. Nickel in a comet's makeup is virtually unheard of, hinting at an origin rich in heavy elements, perhaps even materials forged in dying stars. This wasn't just an interloper. It was a time capsule, billions of years old, carrying fragments of an alien stellar nursery. But the plot thickened with Spherex. Between August 8th and 12th, deep observations revealed the unthinkable. The nucleus might be up to 46 kilometers wide, enormous compared to the interstellar visitors we've seen before. Something this size should have been spotted long ago, yet it slipped into our solar system undetected until now. How? Its chemistry, its structure, even its light scattering, all conspired to cloak it in plain sight. So, what are we really looking at? Atlas isn't just another comet. It's a messenger, a relic from a long-dead star system. Its inverted dust tail, its impossible chemistry, its sheer size, they all whisper of physics and processes we've never accounted for. And time is short. The countdown is on. By October 3rd, Atlas will sweep past Mars at just 18.6 million miles. ESA's Mars orbiters are braced for a close-up look. The last chance before it swings around the Sun on October 29th, vanishing in solar glare, then slipping back toward the dark forever. 4 telescopes. 4 independent confirmations. 1 inescapable truth. Atlas isn't just challenging comet science, it's expanding the boundaries of what's possible in the universe. As this visitor races past, carrying 7 billion years of history, we're left with a sobering reminder. The cosmos is infinitely stranger, endlessly richer, and far more unpredictable than we dared imagine.